I'm Anil Kumar, and now let us understand how to apply the chain rule and find derivative of functions. The question before us is differentiate y equals to square root of x plus square root of x squared plus 5. To find the derivative, it is good to write it in exponent form. So what we have here is outside bracket. So this is my outside function, and the power is half. Do you see that? Then inside we have x plus, and this thing is within the square root. So I'll write another bracket here, x squared plus 5 to the power of half. So that is how you could rewrite your function. Now let us find derivative, that is dy over dx. So dy dx, derivative of this function, which sometimes you may write as y dash also, is equals to, always in the chain rule we apply from the outside. So it is something, let us say something is by u for us, for example. So half of u to the power of minus half. So we could write this as half of all this. All this is x plus x squared plus 5 to the power of half to the power of half minus 1, right? So let me write half minus 1 for the time being, times derivative of inside function. So we'll write d dx of inside function, which is x plus x squared plus 5 to the power of half. So this we could write as 1 over, we have 2 here, and all this is the original function. So we'll write original function, which is x plus square root of x squared plus 5. So in my solution, what you will see is that we will conveniently change from exponent to radical form, right? Now derivative of this function, you could use the sum of derivatives. So derivative of x plus derivative of all this. So we could write this as derivative of x is 1, right, plus derivative of inside function, which is half of derivative of inside function, which is x squared. So let me write this first as x squared plus 5 to the power of half minus 1, which is minus half, right, times derivative of inside function. Let me go one more step here. So it'll be derivative of x squared plus 5. Do you get the idea, right? So that is how the chain rule works, right? Function inside a function. We go from outside to inside. Now let me write this as 1 over 2 square root of x plus square root of x squared plus 5. And here we have 1 plus. So we again have 1 over 2 square root of x squared plus 5 times derivative of this function is 2x, right, times 2x, correct? So let's take this common. So we'll take this common, and then we can write this as 1 over 2 square root of x squared plus 5 times, so let's take this common. So what do we get here is, we could actually cancel 2 and 2 also. So if I cancel 2 and 2, so we have square root of x squared plus 5 in the denominator, and here we get 1 will do square root of x squared plus 5 plus this is x times 1, right, plus x, right? Now this is square of this. You will notice this is square of this. So we could simplify it further, and once you simplify, what you get here is, let me cancel 2 and 2 so that it becomes very clear to you what we did here, right? So that is how we cancel. And x squared plus 5 plus x, that is, okay, I forgot to write x here. This is square of this term, right? So we could write this as square root of x plus square root of x squared plus 5. So that gets cancelled, this and this is square of this. Do you see that? Okay. Now, and in the denominator we have 2 times square root of x squared plus 5. So that is how you could simplify the derivative and write it in this form. So that is how it should be. So you'll note always, this number could be any number. You could take a constant a, and that is the general formula for this particular derivative. I hope that helps. Thank you and all the best.